there's something you can insert.
Okay.
In order to practice, there's something on console you can use to fix that.
So, today we are going to talk about recursion, which is fun. On Monday, we didn't have class, which kind of destroys our rhythm. So I figured, given that recursion is going to be a lot of fun, we are going to spend a week and a half on recursion. Does that make sense? So, assignment 4 will be due not this Monday, the other Monday.
Okay, so we have 2 weeks.
Not quite 2 weeks, right? Which, let me tell you this, just the standard warning, right? If you are going to start Sunday night, right, it doesn't terribly help. The idea is if you can start now and come up with questions on Monday, right? And that's when it's going to help. Right? Recursion is incredibly cool and incredibly weird. But it's normal, right? How do you define your ancestry? Who are your ancestors? Who are the people? Who are your ancestors?
You ask your parents.
It's your parents and their parents and their parents and their parents, right? So it's recursively, right? It's your parents and then their parents and then the parents of those parents and then the parents of those people, right? How many folders can you have in a hard drive? And how many levels of folders? What lives inside folders in a hard drive? More folders, right? More folders, right? Who's your boss? Who's their boss? Who's their boss's boss, right? We tend to have this stuff, right? We tend to have recursion all over, right? It's not surprising that mathematicians came up with the idea of recursion, and then we figure out that it's very useful both as a general mechanism, which is how we're going to see it here, and for dealing with stuff where you have recursion. If you're going to go through every file on your hard drive, right? Chances are that you're going to write a recursive function because a folder has other folders, right? That's obviously how we do define that, right? You're going to go through a database and find all the ancestors, then you're going to have to use recursion. You're going to go to a database and find the ultimate boss, right? Or everybody on your chain of command. Then you're going to use recursion because that's the obvious way. Does that make sense? A lot of the examples that we're going to see now, given that we haven't seen much programming, are going to be super simple and are really going to be over stuff that you could do other ways. We are probably not going to see a lot of stuff that you couldn't do other ways. But the standard example is the definition of factorial. N factorial, which we write it as n bang. You remember from probability? Yes, no, maybe? It's the number times n times n1 of 1, n minus 2, right? All the way till 1, right? It's the product of all the numbers from 1 till n. Another way of defining it is the factorial, n factorial is n times n minus 1 factorial. Right? That's a very simple definition. What's the problem if you start with just that definition? You'd say, okay, 3 factorial is 3 times 2 factorial. Okay, now let me figure out how much is 2 factorial. 2 factorial is 2 times 1 factorial. 1 factorial is 1 times 0 factorial. 0 factorial is 0 times minus 1 factorial. And you keep going, right? So you need some way of stopping the recursion. Does that make sense? You need a condition, right? A stopping condition. For factorial, the common mathematical way is to define 0 factorial is 1. And the factorial function is only defined over positive numbers. If you saw this in middle school, you probably saw 1 factorial being 1, right? But it's the same thing. Does that make sense? So, in Java, we can define a factorial function like this. It's called factorial. It takes an integer and it returns an integer, right? The parameter is called n. And so, if n is less than or equal to 0, we're going to return 1. Why? More properly, it should be equal 0, but I'm paranoid. So by doing that, what do? If you call me with a negative number, I'm going to return 1, which is not quite right, but not wrong. Does that make sense? And then, if it wasn't less than or equal to 0, I'm just going to apply the definition. N times factorial of n minus 1. Right? In a way, there is nothing magical. I have a function, and that function can call other functions. It's not magical, it's normal. Right? Near some 100 can call near 100 and near 200. Right? And near 100 can call is in between. And so we can do that stuff. Right? There's nothing terribly magical, except that you call yourself. You call the same function that you're defining. Does that make sense? Other than that, there's nothing fancy about it. How is this going to work, right? This would work exactly the same as with any other function. So if we call factorial of 4, what's Java going to do, right? What's the code that's generated going to do, right? It's going to come here. It's going to say factorial, okay. N is 4, right? And let me start this execution. Let me put this on the stack and start this stack of executions. Is n less than or equal to 0? No. Then I'll do this. So I'm going to return 4 times factorial of 3. Right? And then, just like with every other function, it's going to see, oh, what the heck is factorial of 3? Let me go calculate it. Right? And so it goes to calculate factorial of 3 is, oops, I have a typo that should be less than or equal to 0, right? It's not, so return 3 times factorial of 2. Factorial of 2 is less than or equal to 0, no. Return 3 times factorial of 1. God. Wait, let me go fix this so we can actually do it the right way, right? One second, sorry. Voltage should be less than, right? And this should be 3 times factorial of 2, this should be 2 times factorial of 1, this should be 1 times factorial of 0. to recognize this stuff. Okay, now it doesn't suck. So factorial 4 is 4 times factorial of 3, factorial of 3 is 3 times factorial of 2, factorial of 2 is going to be 2 times factorial of 1, and factorial of 1 is 1 times factorial of 0. Calculate factorial of 0, I check, oh, it's less than or equal to 0, so I don't need to do any more, I just return 1. And then this stack on 1s, right? So factorial of 1 would return 1 times 1, which is 1. Factorial of 2 would return 2. Factorial of 3 would return 6. And factorial of 4 would return 24. Does this make sense? Is this cool or what? For those of you who are taking discrete math, or who remember your math from high school, what is this related to in math? Permutations, the factorial part, right? But the recursion part is related to what? Infinite series. How do you prove stuff for all the numbers and things like that? Inductions, right? Mathematical inductions, which chances are you will see again in discrete math. It's the same idea, right? And just in case you want to think and play, it is the same idea as a lot of logical paradoxes. This sentence is false. Once you add self-reference, then all hell breaks loose, right? It is the same thing here, except that here we can control it, right? We actually call the same function and it works. Isn't this cool? Isn't this incredibly cool?
How does heuristics play into this?
How does what?
Heuristics. Is that what determines like where you end it? Because we went over that.
Heuristics are rules of thumb. Heuristics define. Heuristics are more rules that don't always work, but that sort of kind of give you the idea. And so many heuristics are recursive, or many times when we look at problem solving, you end up with recursive stuff, but it's not necessarily related. Like a heuristic may be buy American cars, right? Because they tend to be good, or buy Japanese cars because they tend to be good, right? Depending on which heuristic you use, right? Neither one is necessarily true. They sort of kind of probably work, right? And depending on what your parents did 20 years ago, you end up buying the same kind of cars, right? Or not. They bought a Toyota 20 years ago and it sucked, so you stop buying those, right? And that becomes your new heuristic. So, but it's cool that you're relating it to other concepts, your other classes. That's good. Does this idea make sense with factorial? Let's try another one. The power function. You raise something to an exponent. You raise a base to some exponent. Does that make sense? How would we do that? Let me just do it here. Int power, int base. Right? I'll probably type this into JShell so we don't need the noise. For now, right? If we're doing this inside a class and full program, we need to do public static. How do we define that? How could we define the power function? Raise a base to some exponent.
Use a conditional statement.
use a conditional, right? What can be our base? What do we want to use as our base? What's our base case for recursion? What's the thing where we stop going? Its exponent is less than 0 or equal to 0, or what's something raised to the 0th power? 1, right? Okay, so we can, given that I'm paranoid, I'm going to use less than or equal to 0. What do we return? Otherwise, it wasn't less than or equal to 0. What do we return?
Return base times power. Base,
Does this make sense? Isn't this cool? How simple is it to write these things? You need to be careful, right? Your recursive case needs to lead towards the base case, right? We are going lower and lower exponents until we reach 0, right? So you need to make sure that you eventually get there. If not, you fall into an infinite loop, or an infinite recursion.
Now let's return base time.
Yes, you're right.
And it gives me an error if I don't put a return
Yes.
outside of that.
Yes.
So I just
Yes.
deleted the else.
Pair programming is really cool.
Oh, here.
One of the there is a technique for software development, or a set of techniques. One of them is called pair programming. Two people program together, and you end up producing a lot less errors. You see that here all the time, right? Somebody's typing and a bunch of people are looking at the code, and so you will catch a million mistakes, whether I'm typing or whether you're typing. Isn't this cool?
You know, the gamma calculation?
For
The constant gamma.
it's factorial, right? It's factorial.
It's 1 divided by 1 plus 1 divided by 1 plus 1 divided by
Oh.
1 plus 1 divided by 1.
Cool.
Yeah.
We can do that. When do you stop? However you want to approximate it?
It's
or?
a transcendental number, so you never stop.
Yeah, if you're doing, if you're doing calculus, usually the first month of calculus talks about series and things like that. And so you see a bunch of these kinds of things, a bunch of things that would work well with recursion. Let me try to find JShell. Where is JShell?
Can you do the where is command?
Yeah, but it's not there, that's why. But this guy has it. It is there. So I can go system, library, frameworks. And this is horrible stuff from oops. Not JShell?
Jacobs. That's the same.
No. Did I mess up my Java 9? Nah, it's not here. Where is J shell? Okay, I can cheat. Hopefully my server is set up. Haha! Ooh. Okay. Took me a while, but I found one shell. God. Woohoo! It works, right? This is one way. Let's do this. Actually, let me see. Let me confuse you guys a little bit more with power. There is another way of calculating the power. How many times do we call power in this function? If I'm raising something to the 5th power, how many times am I going to call power? 5, right? Maybe 6. Maybe. I don't remember, right? We need to calculate it. Probably 6, right? But if I do something to the 20th power, how many times am I going to call it? About 20, right? This is called a linear process. As your input grows, your computation time grows linearly, right? It is fairly good. Computers are fast, so you can raise something to the gajillion power, right? And it will probably work really fast. Actually, you're probably going to break integers way before you start taking time, right? And you eventually overflow and cannot represent it as an int. But we can do better. If we are raising something to an even power, right? What can we do?
You can do it by dividing by doing exponent minus 2 instead of minus 1.
Well, I could do exponent minus 2, right? Regardless of whether it's even or odd, right? That helps a little, but it doesn't help me tremendously, right? I just do it by half, but if I do something a million times, it's still going to take me, now 500,000 steps, which is better than a million. But if I'm raising something to the 20th power, what can I do? Raise it to the 10th power, and then do what? Square that thing. Does that make sense? Right? So one way, let me call it L for now. And let me try to figure out what we are going to do, and then we'll do the base case. Don't let me run it without the base case. So if the exponent, I can even do this. I can do int square root, right? Or yeah, let me call it square root. So, SR equals power L of base exponent divided by 2. If the exponent is even, what can I return? That thing squared. Does that make sense? If it's odd, what can I return? So imagine that I'm raising something to the 20th power. What I'm going to do is calculate it to the 10th power and return, right, a to the 10 times n to the 10th, which is a to the 20, right? If I'm trying to raise something to the 21st power, what happens if I already have something to the 20th power and I need to calculate the 21st? What do I do? Multiply by base, right? So I'm going to return Does this make sense?
Are we starting to get into like time complexity?
Just to give you guys the idea, you're not supposed to learn time complexity in this class, but it's never a bad idea to start thinking about it, right? And we don't have a base case, so what happens if we run this? We get an infinite loop, right? I tend to write my recursive functions this way. Put my base case, return, and I don't need the else, right? Because I just returned. Does that make sense? And that saves me one level of nesting. I don't like nesting. Eventually my screen breaks. Does this idea make sense? Now what would happen if I call this? Let me actually do this. This is horrible. Don't call system out print line in your functions, but I'm going to do it just to show. So if I raise 2, actually if I raise 1 to the 21st power, right? What's going to happen? It's going to call power L of 1 to the 10th power, right? 10 to the 5th, to 2 to the 1, to the 0, and eventually returns 1. Does that make sense? Why am I using 1? So I don't go out of bounds, right? 2 to the 20th power would work. If I do 5 or something like that, it breaks and returns horrible stuff, which has nothing to do with the number. It just overflows and keeps doing horrible stuff. But if I do 1, that's okay. Now, what do you think is going to happen if instead of doing 21, I do 210? Is it going to fit on the screen or not? Make it 10 times more. About how many lines am I going to print?
2 or 3 more.
How many more?
Maybe 10 times, isn't it?
Not quite. This is not linear anymore.
Oh,
It's only 3 more or something like that,
Yes.
right? Why? Because I'm going by halves.
Yes.
I'm doing about what? The logarithm base 2
Yes.
of exponent. Does that make sense? So this would be obscenely faster for large numbers, right? It would actually break my numbers anyway, but if I was using bigger numbers than ints, right? It would be obscenely faster for large numbers. Because instead of being linearly, instead of doing it 210 times, right? I'm only doing it 10 or something like that. Does that make sense? And if I added a couple more things, what happens? I'm only adding 6 lines or something like that. So logarithms are amazing, right? Linear processes are okay. Sometimes life sucks and you do quadratic or exponential or something like that, and then life really sucks. In data structures, you are going to see those things. This is more to illustrate that your recursion doesn't have to be counting down one by one, right? Here, we are halving rather than going down one by one. Does that make sense? Is this cool or what? Recursion is really cool, right? So we have talked about factorial, we have talked about power. Normally, we write functions, and normally those functions just return values, and they are pure and pretty. Sometimes we need to print stuff. We can also do that recursively, right? Probably should take parameters. Let's do it this way and then change it. I'm going to print the countdown, right? This guy. I don't return anything, so I do void, right? I'm going to print down from that number, right? Until, when do we stop? Do I say 1 or 0 or something like that? Okay, we're going to print 0, right? So if from is less than 0, what do we do? That's my base case. I just return. Don't do a thing. Just get out of here immediately. Do not pass go. Do not collect 200. Now, if it wasn't, right, what do I do? Say you're calling print countdown and from is 5, right? What do I need to do? Print that number, right? And then what else can I do? How do I print the rest of the numbers?
Print countdown from -1.
Right? Call the same function, but now with one less. Does this make sense? Is this cool or what? We really shouldn't be doing this. I apologize. This makes it suck less. Does this make sense? Any other kinds of things that we want to do with recursion? And we can do anything we want, right? Recursion is a completely general mechanism. With if and recursion, you can implement any program you ever wanted. There's nothing else you need. Doesn't mean that you should, but you can. Sorry?
Like a Turing machine?
This is Turing complete. Yes, recursive functions are Turing complete. They are equivalent to Turing machines. They are equivalent to Java. They are equivalent to any programming language. What would be cool? Actually, trying to also remember, let me do one thing, if you guys don't mind. Let me make sure that I don't do any of the assignments. So you need print piece bus is prime. And read within range. Cool. On string times. That's perfect. You can actually do other stuff. Actually, how can we check whether a string contains a character? What can we ask of strings? Do you remember? Could ask them the length. We could ask the character at a given place, right? So, what could we do? This will actually, let me do this. This function will return true how can we know that it doesn't contain it, right? We are going to start, so you tell me start from the 5th character, right? Character number 5, then I'll keep going until the end of the string, right? How do I know that it's not there?
From is greater than.
If I reach the end of the string, right? Does that make sense? So, if from is greater than what? How do I get the length of the string? Maybe. Let's go check. Isn't it cool? We get instant feedback. Okay, it's a method. So, if I'm bigger than the length, then what do I return? False, right? That's my base condition. So I'm going to check that. So what do I need to check now? How do I know if it's there for that particular character? I can do char at 0 is going to return what? abc.char at 0 is going to return what? A, right? B, right? So what can I do here? Check if it is that character, right? So how do I write that? If the corresponding character is equal to what? If it is, then what do I return?
Oh, no, true.
I did it, right? And then if neither one of those was right, what do I return? Whether the rest of the string contains it, right? S, C from +1. Isn't this cool? It may even work. Missing return statement. Pair programming doesn't always work. Ooh, that's cool. We got an off by 1 error, even if it's equal to the length, right? We should still return false because it's 0 indexed. Does this make sense? Is this cool?
Why are you adding 1 to from?
So that now you start looking from the next character of the string. So initially you get...
Looking to the end of the string?
Yep.
Okay.
We could do it the other way around, right? Shall we do it the other way around? Just for fun?
Sounds good to me.
Let me call it contains 2. Here it's more if from is less than 0, return false, right? This is the same thing, but then I'm gonna go to from -1, right? What's gonna be the difference here? How do I call this function? Yeah. Oops. First of all, I need to define it. If I'm gonna call it contains 2, would say ABC again. What do I pass as the from now? Should pass the last character, right? What happens if I pass this in brace, right? Does that make sense, Marcelo? Now, this actually illustrates another important point with recursion. The interface of that function, right? When I'm calling to see whether a string contains a character, that extra number at the end, whether it's a 0 or, right, is kind of an annoyance, right? Whether it's a 0 or a 2, right, or length -1, something like that, is an annoyance. Does that make sense? So what I normally do is write a wrapper function that calls my recursive function the right way. Does that make sense? So I can write this is a wrapper function. It contains 2 SC and S dot length -1, for example, right? So I can just call contains ABC Does this idea make sense? Normally, when you write functions, recursively you tend to write the wrapper. Yes?
I'm sorry, what is the wrapper function get for?
The client, the person outside of you, right, gets a nice interface.
Oh, okay.
I don't need to know whether, right? I don't need to know that you're using a third parameter. I don't need to know whether I should pass 0 or the length of the string -1. It's kind of it's an implementation detail. Outside people shouldn't know. You wash your dirty clothes at home.
So that's what they do when they want to hide the code.
Yes. You just declare it private and then nobody else has access to it. That way, right, in this particular case, what you want to do, you are your interface is a storefront, right? You are trying to give a nice facade to the outside world. They don't need to know whether you implemented it recursively or not, whether you added 1 or 17 parameters, right? They don't care. By the way, I think we mentioned it, but what's the name of this function? What's the name of this function? Does Java get confused? It's overloaded. It has a different number of parameters, right? So as long as your functions have different number or types of parameters, you'll be okay. And Java will find the right one. Does that make sense? I tend to usually not overload, except constructors, eventually, just because I tend to find it 80–90% of the time it's more confusing than just coming up with 2 different names. But if you want to, you can. Does that idea make sense? And I don't think we had actually made an example. I think I mentioned that it can be done, but we hadn't made one example. Is this cool or what? What? Okay. Any questions about recursion now?
So that wrapper function is just calling, is it calling the first example or the second example?
Which one is it calling?
It contains 2, I think, so
Yeah.
I guess it's calling, okay, the one before.
The second example. We could make it called, right? The first example, and then we pass 0.
You just pass 0.
It would work either way, probably. No, it would work either way, right? We tested it. We tried it once. We tried it once, it's thoroughly tested. No, eventually you should try unit tests, but for now, right, we tried it once.
How would you account for like capital letters or anything like that? If they put in like a symbol or
In this particular case, I don't care. You pass me a
it's not
character.
gonna matter?
No, if you pass capital A and you wanted lowercase a, I'm just gonna not return it, right? Does ABC contains capital A? No, those are 2 different letters.
Right, but for like
Oh, you
The
wanted
way that-
something else, we can write it.
yeah, but like the way like you had it set up where you're kind of hiding that kind of like
The wrapper
the
function?
wrapper function. You're hiding kind of like the guts of it. They wouldn't know that, you know.
No, they wouldn't, right? I would need to tell them.
Right.
That's documentation, which is this line here. That's all you'd ever need. Now, this is important, right? those kinds of things are important, and you need to be careful when you define it, right? What do you mean by this? What do you mean by that? You will find both within the profession, right? Within programmers, kind of the default is not to do any extra manipulation, right? So most programmers would understand that this guy doesn't do capitalization, right? Because that's kind of the obvious thing. Normal people may not, right? And so you would need to specify, if you do this and you sell it to somebody or something like that, right? As a library, you probably want to specify that it doesn't deal with upper versus lowercase, right? You need the enterprise version for that, and that one costs $20 per user. No. That's kind of documentation, and many times you as a programmer call it and see what happens. You could Google it, but you could Bing it, but you can just call it and see what happens. In this particular case, it wouldn't do, right? How can we do it? Actually, we can cheat. So you could do this and then
So force everything to lowercase and then compare.
yeah, so that would find it either way, right? That tends to be kind of the common trick, is make everything lowercase. You need to decide whether that is the right thing or not, right? Oh, but I wanted it in Spanish, and so what do you do with A with an accent? Right? So you need to decide what you want to do. Let me undo this. Actually, like this, just for fun. We could do it many different ways, right? What else can we do? How about we do more stuff with strings? Is that right? English, right? Does it have two C's? That's a good name for, give me the index of the first time this character appeared. Yeah, spelled it right. Handmade propaganda for Bing. It's the subliminal stuff that matters. So it's going to return the index of the first occurrence of that character on the string, or -1, right? Can we start like this? Can we do it with like contains 2? Well, we are going to find it in the wrong order, right? So we need to do it like contains, right? We need to count up so that we find the first occurrence rather than the last occurrence, right? So if we fell off the string, what do we return instead of false? If we find it, what do we return? The index of that character, which is what?
Gonna be from.
Mm-hmm. If not, we just return this guy.
You get a from argument.
Sorry?
We need a from argument.
Ah, yeah. We messed something up. Identifier expected. Oh, yeah. From. There's no reason to do syntax. Java will understand what I mean. Those compiler writers are nice.
Close enough.
And then we probably want to write a wrapper, right?
No Xerox.
Sorry?
Strain line, strainers.
Well, depends on where we're counting down or up. In this case, we're counting up, so we start at 0.
Oh yeah.
And the length of the string appears here. Ooh. Now you write it first, and then we write it. How do we know, right? How can we find the last digit of a number?
Mod 10.
Yeah, we do mod 10, and that gives us the last digit, right? And how do we eliminate that last digit? Divide the number by 10, right? And that eliminates that last digit. Right? So, now you can do that. Keep in mind that dividing by 10, right, is integer division. So what happens when you have a one-digit number and you divide it by 10? You get 0, right? So that's kind of your ending condition. You need something to write on, man.
The last part, what does the zero represent?
Sorry?
Zero, what does it represent?
When I'm calling first occurrence, you start from zero. So the first character you're going to compare on that function above, you're going to start from the character zero. And then keep going down. Okay, what would be our base case? When do we know that we are done?
Which is divided by 10 equals 0.
Okay, so if n is 0, right? What do I do?
Return false.
Right? So that's my base case. Now, otherwise, what do I do? If the last digit equals digit, right? We want to define last digit? Nah. And %10 if neither one of those was true, what do I return?
Or no, contains digit.
Yeah. And divided by 10 digit. Woohoo! Isn't this cool?
No, there's a, if you do 0, you do division by 0 and you have
Ah! This is the only problem. Is that a problem or not? Does the number 0 contain the digit 0?
well, that is true.
Kind of depends on your definition, right?
Yeah.
Because normally you never write zeros, right? You never write zeros to the left of the decimal, right? To the left of the number, except for zeros. I don't know.
The 0 can be embedded in the number. 1, 0, 23.
Now that would work, right? If we do 120, for example, right?
But that
It would find 0. The digit can be 0, it's just the number that cannot be 0.
Don't you mod it by 0 at some point?
No.
Oh, you mod by 10.
I mod by 10, yes. And divide by 10, yes. So the only thing is whether the number 0 contains the digit 0. And that's more philosophy. We can solve it by the standard mathematical device of defining it as not. Defining it the way that's more convenient. So no, it doesn't contain it. By golly.
I don't understand how dividing the number by 10 gives you digit.
Okay, here's what happens is, let me actually print, right? Or let's trace it, right? What happens when I called it with, say, 123, right? So I call contains digit of, say, 123 and 2, right? So what am I going to do? Is 123 0? No, right? So I skip that one. N% 10, so that's 3, right? Is 3 equal to 2? No, right? Then I'm going to return contains digit of 123 divided by 10. So what's that going to be?
Didn't it just divide by 10?
No, I did mod, right? The remainder, the rest.
Yeah. So okay, so that's why I had 3 before, and then so what it's going to do then is it's going to look at 120.
No, what happens when you divide 123 by 10? You get a remainder of 3, but what's the quotient? What's the result of 123 divided by 10?
What's the result? 12.
12. So now you're going to call contains digit with 12 and 2, which is this piece. And so now you're going to see, is this 0? No. Let's get the last digit. It's 2. And is that equal to 2? Yes. So I return true.
Oh, okay. So that's. So it just looks at it just slides over and looks at the next digit. After
By dividing by 10, you basically eliminate the last digit and slide it over.
Okay. Makes more sense. Thank you.
Isn't this cool? As you may have realized, recursion is one of my favorite topics. I really, really like it. It's kind of magic, kind of cool magic. Can get confusing eventually, but actually, if you understand it, you're halfway through being a programmer. Because it's also kind of this build simple things that will do whatever, right? Build simple functions and then eventually everything becomes easy to do. So it's kind of the normal corollary of that. Okay, I will see you guys on Monday. Please try to do assignment 4. It is not going to be due Monday, but do try it so that you have questions on Monday, right? One sec. I'm trying to find this thing. One second. Lecture.